Okay, so let's go ahead and prove the sine of a sum identity and the cosine of a sum identity. And we'll also do the differences too. So the sine and cosine of sum and difference. All right, so the two claims that we're going to be proving here in tandem today are as follows. We're going to have the sine of alpha plus or minus beta is equal to the sine of alpha times the cosine of beta plus or minus the sine of beta times the cosine of alpha. Okay, that's the first statement. Second statement we're going to be proving is that the cosine of alpha plus or minus beta is equal to the cosine of alpha times the cosine of beta minus or plus the sine of alpha times the sine of beta. Okay. Now, I was thinking about how to do this. I think we're going to use a geometric argument, set up a nice diagram, and then use the segment addition postulate. I know it sounds really simple, but I think that's going to do the trick here. So let's establish here a right triangle. Okay, there's your right angle there. And there is your first right triangle. And then let's get in also a right triangle here. Okay. And it's going to be stacked on top of this one. So the hypotenuse of the lower triangle is the longer leg of the upper triangle. We're also going to make sure we have this segment coming down. And we want to make sure also we have this segment coming across like so. I think this is going to be good enough to prove our statement here. We're going to call this K, so some constant K. And this will be alpha and this will be beta. Okay. Now, this right here is going to be K times the cosine of the quantity alpha plus beta. Okay. Yes. And then this here is parallel to this. So if this is alpha, then this has to be alpha by the alternate interior angles theorem. But this is a right angle and this is a right angle, so this has to be alpha too. We've got a three-way triangle similarity situation going on here, which can be readily demonstrated. Okay, now this right here is going to be K times the sine of beta. Okay. Okay, good. And then this right here is K times the cosine of beta. So let's establish that. K times the cosine of beta. Okay, yes, that's correct. Now, this right here is going to be this times the cosine of alpha. Okay, so this is K sine beta, so it's K sine beta and then cosine of alpha. Okay. Whereas this right here is going to be this times the sine of alpha, so K sine beta sine alpha there. Okay. We want to label every segment so that we can use the segment addition postulates. Now this right here, okay, is going to be this times the sine of alpha, so that's going to be K cosine beta sine alpha right there. And by the way, this here is the same as this right here. Okay, so we can then add up these segments to equal the whole segment. And what is the whole segment? Well, the whole segment here, This whole thing is just k times the sine of alpha plus beta. So k times the sine of the quantity alpha plus beta. Okay, we have one more segment to identify, and it's this whole segment right down here. And that's, of course, going to be, it's going to be this times the cosine of alpha. This times the, so it's k cosine beta cosine of alpha. Okay, let's carefully check over that and make sure we have committed no careless mistakes. Looks good. Yeah, I don't see any errors here. Very good. So by the segment addition postulate, this segment right here plus this segment right here is equal to the whole segment. And what is the whole segment? Well, the whole segment here is k sine of the quantity alpha plus beta. So it's going to be equal to k sine beta cosine alpha plus this right here, which is k cosine beta sine alpha. All right. Let's divide everything by k. And while we're at it, let's just go ahead and rearrange everything using the commutative property so it can appear like our claim up here. All right, so dividing both sides by k, which we know is never going to be 0. If k is 0, this whole diagram collapses in on itself, right? K is therefore going to be a positive real number. Okay, suppose we should establish that. K is belongs to the set of positive reals. Okay, easy enough. Okay, let's also show the difference. Now that we've shown the sum, let's show the difference. So to show the difference, we can say also sine of alpha minus beta, so just replacing beta with negative beta, is going to be equal to the sine of alpha cosine of negative beta plus the sine of negative beta cosine of alpha. Okay, what is that going to give us? Well, cosine's an even function. So the cosine of negative beta is the same thing as the cosine of beta. So this is going to give us sine of alpha cosine of beta. And sine is an odd function. So the sine of a negative is the negative sine of the positive version. So this is minus, right? Sine beta cosine alpha. Well, there you go. That is now done. Let's put a check mark by that. We've accounted for that first statement, but we still have our second statement to prove the cosine of a sum and difference. Okay, we can use the segment addition postulate for that. This segment right here plus this segment right here will equal the entire segment. And what is the entire segment? It's k cosine beta cosine alpha. Okay, good. That whole segment's going to be equal to this, which is k cosine of the quantity alpha plus beta. Okay, plus this segment right here, which is the same thing as this segment right here. This is a rectangle, right? And what is that segment? Well, it's k sine beta sine alpha. Okay. All right. This worked out quite nicely. Not too bad. Okay, since this is what we're trying to isolate, let's subtract this term from both sides, and then let's just rewrite this using the symmetric property. So we're going to have, and we'll divide both sides by k at the same time. So we're going to have cosine of alpha plus beta is equal to this cosine of alpha cosine of beta. I'm using the commutative property to rearrange those, minus, since this is being subtracted over, sine alpha sine beta. Again, using the commutative property so that the form matches the claims form. Okay, but now we got to show the cosine of a difference. Well, we can do it the same way we did this. So let's do that also. We've got the cosine of alpha minus beta. That's going to be equal to cosine of alpha cosine of negative beta minus the sine of alpha times the sine of negative beta. Okay. Again, the cosine's even. So the cosine of a negative value is the same thing as the cosine of the positive value. So we got cosine alpha, cosine beta here. And sine is odd. So the sine of a negative beta is the same thing as the negative sine of beta. But there's already a negative there. And so a negative times a negative is a positive. So there you go. All right, that worked out quite well. Both of those have now been proven. Hopefully you found this video to be educational. Please leave your comments, questions, concerns, and of course recommendations for future content. We're quite receptive to those. We love proven statements around here. We love derivations. So please do not hesitate to recommend a future topic. Have a great rest of your day, and we will see you in the next video.